Why don't we?
Alright, it's recording just fine, so let's go to Google.
Email rule sheet.
Email. No, it's instant message, You have to respond to the I am, within like 20 seconds.
Just have a random.
And I have to install something on your computer too. Alright, so we are now on topic 7. And there are quite a few things we have to do today. Well, it's interesting what you just talked about a little bit earlier about all the small appliances, anything with electronics. They can potentially bundle spyware, in all of those things. And not only is the spyware going to run on those things, it is also possible for anything that plugs in as a USB device, they can actually make spyware appear as another drive. And then with auto run configured on your computer, as soon as you plug in something USB, the spyware thing can auto run, and then your computer can potentially get infected. Now, what kind of USB thing am I talking about? Just about anything that connects to USB.
Keyboard.
Could be your webcam, can be your camera, can be
Was it auto reply? I've got the feature.
auto
They
run.
implement keyboards too, so they can like.
Yeah, it can be a keyboard, can be that little dongle thing for a wireless keyboard. Anything can be, can contain, spyware and malicious, software. And, it's because, with a single USB connection, it can have its own hub inside, so it can appear as both a camera and a mass store device at the same time. Yeah. So now, if it appears as a mass store device, Windows is very friendly. Windows immediately wants to go and check it out and say, hey, you got a USB storage device here. Let me check it out. Oh, I can find autorun.inf here. Let me run the autorun, program and see what's going to happen. And there you go. If your computer is not patched, that can potentially cause problems. I think the door is not locked. It's just they have to turn and then pull instead of pull and then turn. So anyway, that's really interesting because it really brings up computer security as a really important topic because it's increasingly becoming an important topic. All right. So any questions about what I just talked about? I'm going to pull the screen just a little bit. Right now it's kind of off. Lower portion of it. There you go. All right. Okay, so we have a new homework assignment that's due next Thursday. And originally I was scheduling the midterm to be on next Thursday. I'm going to push it to the Tuesday after that, so that this way we can cover the homework assignment first, and then you guys have a few more days to study for the exam. Okay, so it will be the Tuesday right before Thanksgiving. Okay. So let's take a look at the homework assignment first. It's called Sub 1. And the program looks like this. There we go. This is your homework assignment. Nothing really particularly tricky. It does have recursion, but it resembles one of the programs that I traced as well. Pretty much, as soon as we talk about subroutine calls and recursion. If you recall from a few classes ago, you can see the resemblance between this program and the sample program that I traced right about at that time. So I will kind of leave it to you guys to kind of look up my notes, look up your own notes if you took any during that time, and the trace is not much different from that one. Okay, so here's your homework assignment. You have 1 week to do it, so it's due next Thursday. Any questions about this homework assignment? No questions. Okay, nothing too strange about this one. Okay, so if there are no questions about this one, I'm going to move on and talk about the practice exam. Before every exam, I always give you a practice exam, including the final exam. But this one is for our exam number 2. It's a practice exam. It's just a word processing document. And here are the questions. All right. The first one, is your favorite pre and post condition question. So this one is, once again, has both the backward aspect and also the forward aspect. So I ask you to analyze the following pseudocode, and you probably recognize this code. It's almost the same as what we usually deal with, except this one finds the minimum instead of the maximum. Okay, but it follows the same kind of logic. And I'm also giving you that the post condition, post 5, is z equals 4 and y is less than x. So that is a conclusion. Right after line 5, I come to the conclusion that z has a value of 5 and y is less than x. And I want you to find the precondition of pre1 and make it as specific as possible. Okay, I don't want pre1 to be just true, because that doesn't give me a whole lot of information. So I want you to extract as much information as possible by walking through this pseudocode backwards, starting with post 5, and then go back to derive and derive pre1. Okay, this is a conditional statement. We have talked about this already, but because it was a while ago, most people probably have forgotten a good portion of that stuff. Okay. So what I'll do today is I'm going to work this out step by step. But this part does not require you to be step by step. You can just say, oh, pre1 is blocked. Now, given your pre1, what I want you to do is to use the forward derivation steps to derive post 5 again. By the time you get to post 5, you may find that the post 5 that you derive from pre1 may not be exactly the same as the post 5 that is given to you here. Okay, that may be true, but that's okay. And right here, be sure to explain each step, especially those of assignment statements. In other words, I want you to tell me why you choose a sub operation or a forget operation to derive the post condition from a precondition on a line that is an assignment statement. Okay, so when I work on this, I will point out what is important in this case. Are there any questions about what I'm asking you to do? No questions? All right. So let's go ahead and do it. All right. I don't think the door is locked. Okay. All right, so I'm going to replicate the code here first. Well, maybe I don't have to, because I can show both the pseudocode and the steps at the same time. So this is the way I'm going to do it here. All right, so what we're given is post 5 is given to you, and at that point I know z equals to 4 and y is less than x. That is given to you as a post condition. Okay. Now, the first thing you want to do with a question like this is to spend maybe about 20 seconds to draw a picture. Okay? Because with a conditional statement, having a picture really helps to understand all the different paths to go from here. You can split, and then it has to merge at some point. So what you want to do is to draw a picture, which is a very typical picture of a conditional statement. Okay? So you have two branches. They merge, they split, and then they merge like so. Okay, that's a conditional statement. The condition in this case is x is less than y. Okay, that's the condition that we ask at the split point here. This is the true path, which means it is the then path. This is the else path. So we go in this direction when the condition is false. That's only when you're going forward. Okay. So the question is, what do you do when you are going backwards in this case? In other words, what we are given here is at this point, right after the merge, we know that z equals 4 and y is less than x. That is given to me. All right. So how do I proceed from here? Well, at this point, I do not know which way I came from, okay, because I'm already at the point after the merge. So that means this condition can be implied by this branch here. It can also be implied by the other branch. So I have to say, oh, it is possible that this is coming from this particular post condition here. So I can say, well, maybe, just maybe, the post condition of line 2 is the same as the post condition of line 5. So let's go ahead and see what happens when I make that assumption. Okay? Because post 2 definitely feeds into post 5, so it is one of the possibilities. So we will say, what if that is the case? Okay, so let's say this is the result of line 2. Line 2 is pretty easy. All we are doing is copying the value of x to z. So as a result of that copying, we get z equals 4 and y is less than x. So can I say something about pre-2 in this case? What can I say about pre-2 in this case?
X less than 1.
Well, let's look at these two things first. Okay, can I keep z equals 4 in this case?
Yeah.
No, I cannot, because it's not reversible. Okay. Now, in the AM class, I kind of explained this already in using a kind of graphical way. So I'm going to do exactly the same thing here. The reason why we want to see whether the right-hand side is a reversible function of the left-hand side is like this. Okay, so what a function does, okay, so let's say this is function f. What a function does is it is just remapping values to another value. So this is one potential function f here. So I can have, it's just a map, okay? It's really kind of convoluted in this case. But nonetheless, there's one thing that is unique about this, okay? This is where I'm coming from, okay? So I can say this is the, well, I'll just say this is my origin, and this is my destination. And the function, basically goes in one direction. In this particular case, I can start at different origin, but if I start at a different origin, I'm guaranteed to arrive at a different destination. In other words, each origin has a different destination. Is that okay so far? So that's one way to look at a function. All it does is to map certain values as starting points to a destination. If I know that I somehow ended up here as my destination, in this particular case, can I figure out where my origin was in order to end up here? Can you trace a way back to a single origin point or point of origin? The answer is yes, because there's only one path. So if I know that I ended up here, I can just backtrace myself and say, oh, okay, this is where I started in order to end up here. And I can do the same thing with every single possible destination in this case. Okay? So that means for this particular function, it has an inverse. I can start from the destination and go back to a single point of origin. Are we doing okay so far? Okay. What I have here on line 2 and also line 4, they're basically similar things. What I have here is I have in the origin, I can have multiple origins. Okay, doesn't matter which way I start because they all end up at the same place. That's what we have here on line 2 and line 4. It doesn't matter what z was before the assignment statement, they always end up having the value of x or having the value of y. So this is my origin or point of origin. This is my destination. So now the question is, because we're walking backwards, so the question is, if I know that I somehow ended up here, can I go back and locate a single point of origin? Not in this case. Okay? So in this case, there is a function. Okay? The function f is defined because it's only going this way. Okay? Every single point of origin maps to a single point. That is okay. But going in the opposite direction, I do not have a inverse function, because starting from a single point of destination, or starting from a single destination, I cannot trace my way back to a single point of origin. Is that okay? All right. So knowing this, now we're looking at line 2, in the code. There's no way for me to reverse the operation. Even though I know that z has a value of 4 after the operation, I cannot reverse that operation and find out what z was before the assignment statement. Is that making any sense? Okay. So that means I cannot keep that piece of information. I can keep this one. This one is not a problem, because if you look at line 2, the assignment statement does not affect y. It does not affect x either. So y is less than x still has to be true at that point. Now, some people can look at this and say, oh, but since the assignment statement is copying the value of x to z, and knowing that z ends up with a value of 4, doesn't that also tell us that x equals to 4 before the assignment statement? Yep, absolutely. Okay, you can definitely make that inference and say that x equals 4. But there's one problem here. Because in order to be in the then branch of a conditional statement, the condition itself has to be true. In this case, the condition is x is less than y. So that has to be true as a part of pre2 as well. So I have to include it, because otherwise I would not be in the then branch. But now we have a little bit of a problem, don't we? Because now we have basically y is less than x and x is less than y, and then the other one is not really that important anymore, because if you focus on these two conditions, they cannot be true at the same time. But in order for the conjunction to be true, they both have to be true at the same time. So what we have here is a contradiction. In other words, something that has to be false. So pre2 is essentially false, which means the then branch in this case is a dead branch. I could not have come from the then branch in this case. Are we still doing okay so far with this analysis? Okay. I can do about the same thing with line 4. I can say, well, maybe I came from the else branch here. In that case, post 4 would be the same as post 5, which is basically, z equals 4 and y is less than x. Because that's the other way I can get to line 5. In other words, here's my pen. In other words, I can say that, oh, since this path is not possible, maybe I came from the other one. Now, sometimes it is possible in both cases. In other words, it could have come from either one, and then you have to be careful in that case. Okay. So this is the post condition of line 4. Line 4 is just copying the value of y into z. So what can I say about pre4? Okay, it's the same kind of analysis. Okay, so let's go ahead and take a look at pre4 here. In pre4, for exactly the same reason, I cannot say anything about z anymore, because I only know that after it got a value from y, it became 4. But I have no idea. There's no way for me to reverse that operation and say, oh, z had its value before the assignment statement. There's no way that I can do something like that. So I have to toss that piece of information away, but I can still retain this part here, because line 4 does not change y, it does not change x. So that means if y is less than x is true after the assignment statement, it still has to be true before the assignment statement, because nothing can affect that. We can also say that y equals 4, because z got a value of y, got its value from y, and it became 4. So that means y has to have a value of 4. So in this case, I can make that inference and say that y has a value of 4. And because this is in the else branch, I can also tell that x is less than y has to be false, because otherwise I would not be in the else branch. Is that okay? This is the first statement, the only statement in the else branch. So the precondition of the entire branch has to basically say that x is less than y has to be false, because otherwise I would not be here. Okay, so let's rewrite this one a little bit here and see whether we can simplify this a little bit. It is not the case that x is less than y. We can kind of rewrite this one as y is less than or equal to x. Are we doing okay so far with that conversion? X is not less than y is basically saying exactly the same thing as y is less than or equal to x. Now let's go ahead and regroup things a little bit. So things that are kind of related are next to each other so that we can analyze that a little bit better. Okay, so let's look at this part here. I think y is less than x is an expression that is somewhat related to y is less than or equal to x. Okay, I would even say that one is inclusive of the other one. In other words, if one is true, the other one has to be true. But I have to know that direction clearly. Okay, I have to say, but which one implies which one? What do you think? Do you think y is less than x implies y is less than or equal to x? Or do you think y is less than or equal to x implies y is less than x?
Y is less than or equal to x implies y is less than x.
It's the other way. Y is less than x implies y is less than or equal to x. In other words,
Yeah,
okay.
you're removing one possibility.
Right. Okay, when we say A implies B, what it means is when A is true, B has to be true. But it doesn't say anything about what happens when A is false. When A is false, B can be false, but B can be true too. So in this case, we have, we have y is less than x implying y is less than or equal to x. Because if y is less than x is true, y is less than or equal to x has to be true, but not the other way around. Okay, when y is less than or equal to x, it does not imply that y is less than x, because what happens when y equals x? This is true, but this is false. So that's why in this case, y is less than x implies the other one. Okay. Now, that also means that this one is the more restrictive one. And in a conjunction, when you have two expressions, one implies the other one, you have to choose. You can choose the one that is implying to basically be the only one, because that's a simplification. Or in some other term, it basically says you can keep this one here, but it doesn't do anything. Okay, it doesn't do anything to the entire expression. So you might as well simplify this and just boil it back down to just that. Okay. All right. So now that we have pre-2 figure out, which is just false, and then we have pre-4 also figure out, which is this here, y is less than x and y equals to 4. Now, what do we do about pre-1? Because that's our quote-unquote destination. This is the first part of the question, is to figure out what exactly is pre-1. How do we figure out pre-1 here? Well, I could have come to pre-1 from either path, because I'm walking backwards. I have two paths to get to pre-1. One path is this one, which basically is false. The other one is this one, which is basically y is less than x and y equals 4. Well, we'll do exactly the same thing as the destination here. We'll just say, well, it can be or, okay? Because by the time I merge the paths, I would not know which way I came from. So pre-1 becomes pre-2 or pre-4 when we are analyzing the algorithm in a backward way. And then some people will say, but that's not going to work because pre-2 is false. We already know that pre-2 is false. It doesn't cause any problem. You can say false, or in this case, y is less than x and y equals 4. That's not a problem, because false is kind of like 0. Okay, if you look at the row of the value false in the disjunction, it's similar to the row of 0 in addition. It is the identity. In other words, false or whatever is just whatever, because 0 plus whatever is also whatever. So in this case, I can just simplify this and come to the conclusion that, okay, this is my pre-1. Are we still doing okay at this point? Now, some people can even go one step further, which is not necessary in this case, because if you know that y equals 4 and x is greater than y, you can also say that x is greater than 4. Okay, most people like to write it out this way. Yeah, you can definitely make that inference and say that x is greater than 4. Not a problem. But it's not anything extra that we cannot derive from what is already stated in pre-1, so it's not needed. Okay. So now that we know what is pre-1, now we have to go forward again to our post-5. Okay? What you do to come to the conclusion about pre-1 is up to you, and you do not need to show me the steps. But when you go forward, I need to look at all your steps to make sure that you know how to derive the post-condition of a conditional statement. Okay? So from here on, these are the things that I'm expecting from your answer, at least with this particular question. So what we'll do is we'll say pre-2 is pre-1 and the condition of the conditional statement. Have we seen this template before? Yeah, because the precondition of the entire then branch is the precondition of the conditional statement itself and also the condition of the conditional statement, because otherwise we would not be in the then branch to begin with. Well, it's not too bad. I mean, we can just say y is less than x and y equals 4 and x is less than y, and we come to the same conclusion that pre-2 is false, which is good, okay? Because that really should happen, okay? If you go back in a way that is logical and then you go forward again, you should come to the same conclusion at exactly the same point. What about pre-4? Well, pre-4 is pre-1 because we haven't had a chance to modify anything if I'm taking the else branch right at the beginning of the else branch. And the condition of the conditional statement also has to be false. Okay, so in this case, we have y is less than x and y equals 4, and y is less than or equal to x. And we can simplify exactly the same way, so we end up with just this part here. But isn't that exactly the same pre-4 that we came from? Yeah, it's exactly the same, which is good. And then now we can try to derive post-2. But pre-2 is false already. How can we derive the post-condition when the precondition is already false? Well, trust me, it's going to work out. Okay? But before we work on post-2, we have to decide which operation should I use. When we have an assignment statement, what are the two possible ways to derive the post-condition from its precondition? What are the two ways to do it?
Substitute or forget.
Substitute or forget. Okay? How do we decide which one that we should use? I just drew the picture today.
We have an inverse we can substitute.
Right. If we have an inverse function, we can use the substitute operation. If we do not have an inverse function, then we have to use the forget operation. Right. So in this case, we have to look at f of x is the right hand side. Oops, I take it back. I take that back. Okay. F of z equals x is the right hand side of line 2. Okay. Is that reversible?
No.
It's mapping every possible value of z to a single point, which is the value of x at that point. I don't think it's reversible. Okay, it has no inverse, so we have to use the forget operation. Okay, so here comes the fun part. How do we apply the forget operation when a precondition is false to begin with? Well, we do exactly the same thing as we always do. We say forget in pre-2 whatever mentions the variable z, we have to forget it, okay? But on top of that, we can now say something, because we can say, hey, after the assignment statement, we know that z and x will be exactly the same, because that's what the assignment statement is going to do. So you have to remember that this part here is outside of the forget operation, because otherwise it would make no sense whatsoever. Okay, so now we apply that really strange operation of saying, oh, pre2 is a constant of false, and we are trying to forget, anything that mentions z, and then after that we say, and z equals x. All right. Maybe it's not so strange after all. Does false as a value mention z whatsoever? No. So we can keep the whole thing, right? So after the forget operation, we just get the constant false back. No problem. And then we have this one on the outside. From what we already understand about short-circuited evaluation, what can you make? Can you make a conclusion just looking at the left-hand side of this expression? The whole thing is false. Okay, very good. Hey, not a problem. I can actually apply the forget operation to a precondition that is false. Great. Now we can move on to post 4. Okay, post 4 is basically in the same boat. We can just copy and paste this a little bit here, and say that f of z is y in this case, and that's the right-hand side of line 4. Once again, it has no inverse function, but this time, the forget operation might have something to do. Okay, we are basically forgetting anything that contains z in the precondition, and the precondition is just y is less than x and y equals 4. And then after that, we can make the conclusion that z equals y. Maybe there isn't anything to do, because if you look at the expression of pre4, it doesn't mention anything about z anyway. So there's nothing to forget. We can keep the entire thing, but then we can also add this one little piece of information that z equals y at this point. Are we doing okay so far with post 4? Is this kind of like reminding you something about the pre and post condition thing? Yeah. Okay. All right. So now we have post 2, we have post 4. Because of the structure of the program, post 5 is post 2 or post 4. The fact that post 2 is false to begin with doesn't matter. Okay. This is true because of the structure of a conditional statement. Whether a branch is dead or not does not affect the structure of the conditional statement. So post 2 is false, and then post 4 is this part here. And we can simplify the false out of the entire thing, because false or whatever is just whatever. So I can just simplify the whole thing to this part here, which is slightly different from what you were given with. Can anyone spot the difference between the post 5 as a conclusion after the forward derivation from the post 5 that was given to you?
Y equals 4 and z equals y.
Yep, we actually gained something. Okay, let me just kind of scroll this up and so that you can compare. This is the post 5 that is derived. This is the post 5 that was given to you. That's why in the description I said it's okay. If they don't look exactly the same, it's fine. Okay, it's not a problem. All right. Are there any questions about number 1? No questions? Okay, I'm going to give you guys a little bit of time to copy it and catch your breath before we move on. All right. Let's move on to question number 2. Okay, so here comes question number 2. Question number 2 is kind of fun too. It gives you the values of elements in an array. So we have an array A, it has 4 elements. The first one has a value of 2, second one 0, third one 3, and the fourth one, the last one, has a value of 1. I want you to evaluate just an expression for me, which is this expression here. Okay, but you have to do it step by step. Okay, giving me a single value as the final answer is not going to get you any points. So you have to do it step by step. So let's go ahead and do this step by step, and I'm going to do it inside my little text editor here. Okay. So to do this step by step, this is what I mean when I said do it step by step. Okay. The first step is basically to look at the innermost portion of everything and say, okay, what is the only part that is known at this point? 0 is the only thing that I know that is a constant. Okay, 0 is 0, no problem. But because I know 0 is a value and it is a valid index into the array A, I can now resolve what is A bracket 0, which is essentially the value of the first element in the array, which is 2. Okay, so that whole thing boils down to just 2. And then in the next step, I look at this whole thing and I say, hey, I know how to do this now because A bracket 2 is really just trying to refer to the value of the third element in the array. In this case, that turns out to have a value of 3. Okay, so we just say, okay, we can now boil that one down to 3. And then at this point, I can say, oh, but I know how to get to A bracket 3 because it is just the fourth element in the array, which has a value of 1. Yep. And A bracket 1 is just the second element in the entire array. It has a value of 0. So we're back to 0 again. That's it. That's the step-by-step simplification of this particular question, of this expression. Okay. What it is testing is actually multiple things. It's testing whether people can distinguish what is the index and what is the value of an element in an array. Okay? It's testing whether people understand that you can have anything to serve as the index of an indexing operation as long as the index, the value, is within the right range. Okay? It doesn't matter whether it is a value of another element in the same array, as long as in this case it is between 0 and 3 as an integer, it's okay. We can use that as an index. Yep.
What would you do if one of the values was 5?
Then you will have access out of bound. Then you will say so and say that this is not going to work because you'll be accessing an array out of bound, and that's okay. We will have an example where intentionally you have to make your algorithm to generate that error. Yep. Okay, so are there any questions about number 2 at this point? Okay, the most important part about number 2 is the transition. From this to this is worth 1 point. From here to here it is worth 1 point. From here to here it is worth 1 point. From here to here it is worth 1 point. If someone gives me just a 0, it is not worth any point. It does not worth any point if someone gives me just the final answer. Okay, it's the steps that count, not the final answer. Okay, any questions? Number 2. No questions? Let's move on to question number 3. Question number 3, I don't think it's really too complicated. Trace the following pseudocode given the partial trace. In other words, I'm giving you a partial trace here, and you have to basically do one single iteration of the loop. The following is a partial trace referring to this table here. Don't mind that the value of x and y may not make any sense because if you add up 4 and 5, it gives you 9. But the loop can only add 1 to either x or y, or nothing, or none of them. So that means with an array of only 4 elements, it seems like it's not possible to end up with the values 4 and 5 in x and y. But I did not tell you whether x and y started off with initialized with some values or not. So that's possible. So do not get concerned about that part. Continue the trace for another iteration until we get back onto line 1 again. All right. So let's go ahead and trace this little algorithm. See what's going to happen next. Okay, so line 1 is done. Okay, even the condition is evaluated. It is true that I, which has a value of 1 at this point, is less than bar a bar, which is 4 minus 1. That makes it 3. Okay, so where do we go when the condition of a loop is true? We go to line
3.
Come on, 2. Okay, so we go to line 2, which has its own condition to evaluate. In this case, we have a bracket I. Okay, so let's take a look right now and say, okay, what is a bracket I at this point? A bracket I is referring to a bracket 1, which has a value of 1. Very good. And I'm comparing that to a bracket I plus 1. What is a bracket I plus 1? Close bracket. It's referring to a bracket 2, and a bracket 2 has a value of 1. 1 is less than 1 is false. Very good. Okay. So with this one here, the trick is to understand where you are performing the addition. You are adding 1 to I before you do the indexing. Okay? That is the important part. It's not a bracket I close bracket plus 1. The plus 1 is inside the bracket. So you have to add 1 to I first and then do the indexing. That's the second step. Okay, so the condition of line 2 is false. Where do we go? We go to line 4. Line 4, yes. Okay, line 4 has this condition here. 1 is greater than 1 is, once again, false. Okay, and then where do we go? This is a multi-branch conditional statement, but I don't have an else. We get to line 7. Very good. Line 7 is just adding 1 to I. So this time, for this iteration, I'm not even adding 1 to x or y because it's neither less than nor greater than. So now we add 1 to I. We go back to line 1 again. And then we reevaluate I, which is now 2. 2 is less than 3 is true. And you're done. I don't need you to finish the entire thing. I just need one iteration, including back to the first line of the pre-checking loop. Are there any questions about this one? Number 3.
What's the purpose of just doing one iteration?
I can already tell whether people understand quite a few concepts, right? I can see whether people understand, when you have a bracket I plus 1 close bracket, whether people are doing the plus 1 inside or outside of the square bracket. Okay, that's one fairly common mistake. I can tell whether people can understand how to trace a multi-branch conditional statement. Okay, whether they go for the second one or not. I can see whether people understand nesting, because line 7 is at the same level as the multi-branch conditional statement, so it has to execute after you get out of the conditional statement. I can tell whether people understand the behavior of a loop is you have to go back to the beginning after you perform one iteration. So I can tell quite a few things just by going through one iteration. Okay. All right, so that's number 3. And let's move on to question number 4. Okay, number 4 and number 5 are my favorites. Okay, number 4 is a really cool one because this one. Okay, I have to shrink the font just a little bit so I can show the other part. Okay, so the question is asking, even with short-circuited Boolean expression evaluation, the following code is still problematic. Okay, it's still having a problem. Finish the following trace. Okay, and that means the trace over here. Start with filling in values for the two elements a bracket 0 and a bracket 1, so that the trace will attempt to access an element out of bound. Then actually trace the algorithm until the problem happens. If you think the algorithm is fine and it is impossible to access an element out of bound, explain why you think so. Okay? In other words, in this case, the program is problematic. There's a fault in it. Okay? I want you to come up with a test case for that fault to actually happen. That's what I'm asking. Okay? So what do you think? What should I put here into a bracket 0 and a bracket 1 in order for this algorithm to actually access something out of bound? Okay, the first thing you want to do is to think, okay, what possibly can cause this algorithm to access something out of bound? Okay, so I'm going to point out, the various portions here. So I'm going to point out this one here. is it possible for this entire statement to access the array out of bound? No. The only time you can access an array out of bound is when you see the square brackets. Okay, because the square brackets means I want to access something in an array given the index of that element. Line 1 doesn't even contain anything like that. There's no square brackets. Okay, moving on to line 2. Oh, line 2 does have some square brackets here, but let's just be thorough and make sure that we cover everything. Can the evaluation of this comparison generate an error, like accessing something out of bound? What if I is 20? Can I compare 20 to 2? Absolutely. Okay? So that means this part of the conjunction cannot, access an element out of bound because, do you see any square brackets here that I'm highlighting? No. So without square brackets, I cannot access something out of bound. Okay, well, that doesn't really work. Okay, let's look at the other part. Oh, we got 2 of these things. We got a bracket I here. Okay, so the question is, how do I get to this part of which is the right-hand side of a conjunction? How can I get to the right-hand side of a conjunction with short-circuited Boolean evaluation?
I has to be 0 or 1.
I has to be 0 or 1. Okay, so if I is 0 or 1, would this give me any problem? In other words, is 0 and 1 both valid indexes into that array with 2 elements? Yeah. It's in the trace, we do have one column for a bracket 0, another column for a bracket 1, so it should not have any problem. Doesn't that kind of leave you to only one possible choice left? Okay. So now we look at the second one and say, oh, okay, it must be this one. Okay, so if you look at this one here, when do you think the expression inside the square bracket will become too big so that it is no longer a valid index? When it becomes 2, right? When the entire expression has a value of 2, then a bracket 2 is going to access an array out of bound. But in order for I plus 1 to be 2, what do you think I has to be? I has to be 1. Okay. So we want to make sure that we can at least get to the point when I becomes 1. But I was initialized to 0 on line 1. So that means we have to go through at least one iteration. Then the second iteration is going to be the problem. It's going to have the problem. Okay. So now you have to say, well, but how do we get through at least one iteration? Well, we can only get through at least one iteration when both conditions are true for one after the first iteration, right? So what do you think we have to put into a bracket 0 and a bracket 1 in this case? 0 and 1 will work, okay? As long as column D has a value that is less than column E, it's going to work, okay? So 1 and 2 works, 1 and 3 works, 0 and 1 works. It doesn't matter. I'm not going to choose 0 and 1 just so that we don't get confused about the index versus the value. So I'm going to pick something that is a little bit different. So I'm going to pick 3 and 7. Okay, that's going to work. Okay, so let's go ahead and trace this algorithm and see how it's going to access an element out of bound. And I still have to shrink it just one more time, just so that we can see both the trace and also the algorithm. Okay, line 1 initializes I to 0. Line 2 is evaluating the condition. I is 0. 0 is less than 2 is true. A bracket I is a bracket 0. It has a value of 3. Less than a bracket I plus 1 close bracket. I plus 1 is a bracket 1 is 1. So we are accessing a bracket 1 which has a value of 7. 3 is less than 7 is true. So we have true, and the entire thing is true. Then we move on to line 3. Line 3 is just adding 1 to I. I goes from 0 to 1. Then we go back to line 2. And this time we have a problem. Because I is less than bar A bar, not a problem. A bracket I, not a problem. But a bracket I plus 1 is going to be a problem because a bracket I plus 1 is going to access a bracket 2, which does not exist. Okay? Okay, so I'm going to say as a problem. Okay, and that's it. Are there any questions about number 4? I like this one. It doesn't involve any construct that we have not talked about. Okay, we have loops, we have array operations, finding the size of, and also the indexing operation, and it's even relatively short. Okay, it also has short-circuited Boolean evaluation. But nothing that we have not talked about. But it does require you to really kind of think about it. To analyze the code, to think about it and say, how can I break this program? Okay, here's my question. Let's say we have 2 employees, and both can write programs, but one also has a special talent of breaking somebody else's program. Which one do you think will get a better pay? Go ahead.
Oh, the one that can break programs?
The one who can break programs. Yeah, the one who has a special talent to break programs. Why do you think that is the case?
You can find mistakes.
Exactly, before the product is released. Okay. Now, the person who can break programs has a lot of potential possibilities. Okay. That person can act. Go ahead. Oh, I thought you had a question.
No.
Okay, so that person can become, what we call a test engineer, working for a software company, and the job is really to make sure it's quality control for software, basically.
Okay,
so that's a typical kind of job, and a lot of times, those people are, they're not respected, because people think, oh, it's just easy. It's an easy thing to test programs. It's not. Okay, you can already see that it takes a lot of analysis to figure out how to break a program. But that person also has the possibility of becoming a white hat, a black hat, or a gray hat. Okay, what are those terms referring to?
Hackers.
Hmm?
Ethical hackers. And
Hackers.
black
Yep,
hackers.
exactly. A black hat is a malicious hacker. A white hat is someone who's hired to assess the security of an information system, and a gray hat is kind of in between. Right. Yeah.
They just send in feedback just randomly.
A gray hat, can be someone who's doing it, quote unquote, for fun, for entertainment, as a challenge. It's like, oh, let me see how I can break this program, but not necessarily.
But if you piss them off, you'll.
Yes, the DMCA, is intended to turn all the gray hats into black hats, right? So they all fall into one category. They are not white, and off they go. Yep. But those people, all hackers have this special ability to break something, and they all have superb skills in terms of analysis and analyzing things. You give them a little bit of a clue, and they can run with it and figure out what is causing a problem, or why is it working this way. If Sherlock Holmes were in the current days, he would make a great hacker. And so would Moriarty, his nemesis, Professor Moriarty. I only learned about that name from Star Trek: The Next Generation. That's literature for me. Okay, question number 5 I also like a lot. It's the recursive version of binary search. In other words, it is something that we have talked about already. We talked about the iterative version of this algorithm, and now here's a recursive version. You look at the algorithm and go like, wow, that's really a lot of lines of code, and it's recursive, and it's using subroutine invocation and stuff like that. So it has to be pretty hard, and it's going to take a long time to get through this one. This one, compared to question number 4, is pretty easy. It's very mechanical. This one is really just saying, okay, I'm going to run the program exactly the way that the machine would, and that's it. There's not a whole lot of analysis involved in this particular question. Okay, so we'll go ahead and take a look and follow the instructions, right? Continue the following partial trace until both return line number columns are deallocated. Okay, so that means what I'm giving you here is already, I have already run the program quite a bit already, and that's how I got to this point. In other words, you're not tracing from the beginning of the entire algorithm. I'm currently on line 2, and I'm done with line 2 already. Line 2 has already figured out the new value of m, and so I can now continue with line 3, right? So that's what you have to do in the test. Is when you see something like this, that means you just kind of move on and go on with line 3. Okay, line 3 has a condition to evaluate. It has a bracket m is less than k to evaluate. M is 2, a bracket 2 has a value of 5, and then k has a value of 2. 5 is less than 2 is, okay, that's false. We move on. This is a multi-branch conditional statement, so we move on to line 5. On line 5, we are comparing in the opposite direction, so it is true. 5 is greater than 2 is true. So we go to line 6. Line 6 is computing m minus 1 on the right-hand side. M is 2, 2 minus 1 is 1, and we update e with that value. E becomes 1. We are done with the multi-branch conditional statement. We move on to line 8. Line 8 is a conditional statement. It compares a bracket m, and it's asking, is that different from k? Yes?
Just really quick, the one that we just did for line 6, you were taking the value of m, and so the 2, you're doing minus 1, and not, and it was replacing, just in e, right?
Right.
Okay.
Yep. Okay, so now we are evaluating the condition on line 8. A bracket m has a value of 5 because m has not changed all this time, so a bracket 2 has a value of 5. K has a value of 2. 5 is different from 2 is true. Okay, but this is a conjunction. Just because the left-hand side is true doesn't mean the entire thing is true. So I have to do the other comparison as well. B is less than or equal to E is, be careful because we just updated the value of E. So that is false. So now we have true and false, and the entire thing is false. Okay? So that means I don't have to do line 9. So there's no more recursive invocation anymore. And then where do we go? The condition of line 8 is false. So where do we go now? We go to line 11, because line 11 is after the conditional statement. And what do we do when we are at the end of a subroutine? We got 2 things to do. Okay, before we deallocate, we have to use it first. Right. So we look up the rightmost active return line number. In this case, is column L. It tells us to continue execution again on line 11. I make a note of it, but for this line 11, which is what I'm executing at this point, I have to indicate that the return line number column is now deallocated. All right, so we get rid of this one, and then we continue execution on line 11 again. But that's okay, because on line 11, we do exactly the same thing. We look up the rightmost active return line number. In this case, it's column K as the value of post. We make a note of that, and then we deallocate column K. So column K will now be deallocated. So I'm just lazy here, just copy and paste. And then we continue execution at post. We're done. So it's not quite as long as you think it is. It looks really awful, but it's not. Now, one thing that you can do with this one is you can try to do it from the beginning up to the starting point of the question. That is something that you can do. Okay? And I'm not going to show you the quick way to do it, because there is a really quick way to doing it. Some of you may probably figure it out just by looking at the screen right now. There is a clue of something that you can investigate. I'm not going to say it. This is neither your homework assignment nor a suggestion, but there's something here. But you can always just start from the beginning. K and all the elements in A, they all have to be initialized before you start the entire algorithm. So column F to column J, you kind of have to make the assumption that they start with 2, 1, 3, 5, and 7 to begin with. But after that, you can start execution on line 12 and see if you can execute and trace the algorithm up to the starting point of the question itself. That's just a suggestion, okay? Something that you can you can do to kind of practice, as a just as a practice question, okay? Does anyone feel particularly anxious that I'm combining the concept of subroutines with the concept of array indexing and binary search? No, it should not. I mean, it's because they are very different. They do not conflict with each other, and they don't even give you anything that is kind of special. I mean, they mix really well. All right, so we are done with question number 5, and that's the last one in the practice test. Are there any questions? Yep.
So we won't have any local variables?
I think I'm going to ask local variables in the next one.
Okay.
So which means you have to retain that knowledge.
Yeah.
You're looking forward to local. I think this is good.
Stuff in college? I don't know what you're talking about.
I was
Yep.
curious, just out of curiosity, for the floor, in like, C++ or some other language, what would floor be called?
If you do a regular division, it's automatically taking the integral portion of the result. So it's for positive quotient for positive numbers, it's automatically doing the floor when you have integer divisions.
Integer. Okay.
Right. But for divisions that involves negative values, I'm not as sure whether it's just truncating the fractional part, or whether it's doing the floor. I think it's just getting rid of the fractional part. All right. So if there are no questions about this, we'll continue. And this class is a little bit ahead of the other class, so we are, now on a. We talked about passing by reference already. And I think in the previous class, I kind of explained why, even though it is useful, because it allows a subroutine to access a variable or a parameter that does not belong to the subroutine, right? Because it's a wormhole. It is a Stargate. Okay, you can dial the Stargate, and then you can reach out and touch something that is not inside the base of Stargate. Okay, so that's nice. However, it is really cumbersome because I cannot utilize the result of a subroutine in another expression. Okay, let me give you an analogy of what we have at this point. So let me use Notepad is good. Okay, I'm going to use a new Notepad for this discussion here. So what we have here is the ability to do expressions. Okay, we can evaluate expressions. Okay, so we can. Okay, let me give you an example first. So we want to calculate 2 times 4 plus, and then 5 over here. And then we also want the entire thing, and I'm just adding extra parentheses here, and say we want to divide the whole thing by 3. Okay, we all know how to do this by hand. Okay, in fact, most of you can probably just look at this and go 6. Right? Okay, that's no big deal. But what we have here is the ability to pass a result back, but I have to store the result into something first before I can use it again. That is the limitation of passing by reference. Yes, you can pass a result back to the invoke statement, but the only way to pass it back is to store the result into something, and then you have to refer to that something later on. So in order to evaluate something like this, what I have to do is to create at least one variable, not necessarily global, but I need one variable to do something like this. I have to say r gets 4 plus 5, and then I will have to say, oh, what am I going to do with 4 plus 5? Okay, we have to multiply that by 2. And then we say, but what do we do with the product of the entire 2 times 4 plus 5? We have to divide it by 3. So this is what we have to do if the only mechanism we have to pass a result back is by reference. Because the result has to be stored in something, and then in another statement or in another invoke statement, you can make use of the result. I mean, what if this is how you have to do your math in a math class? For any operation that requires two sides, you can only do it like this. You cannot do anything that is nested anymore. Well, you can still do everything that you need to do in a math class. It's just very cumbersome. So we want to kind of not have to do this, and the mechanism we're going to use is the return value. Okay? So return value is going to kind of solve this problem for us. So what I'll do, assuming that all of you have read my notes about return values, I'm going to start with an example. And I can actually see who has read the notes before the class too. But I'm afraid to check. Okay, so let's go ahead and define a subroutine. And I'm going to say define sub, let's call this 5. Because that's all it's going to do, is to return a value of 5. And define sub. Wow. A very profound subroutine here. Well, we haven't really talked about the return statement. Some of you have some exposure to programming already, and you would think, hey, I know what this is going to do. You probably do, but the question is, how are we going to represent the operation of returning a value in this class in a trace? Remember, everything that we do in this class must be represented somehow in a trace. So I need a way to represent this in a trace. So in main, we're going to have a local variable x. And I'm going to say something that is kind of strange, because I'm going to say x is getting the result of invoking the subroutine called 5. All right, so this is my entire program, my entire pseudocode, to illustrate the most basic idea of what is the concept of returning a value. The most important part, obviously, in this case, is line 2 and line 6. Because everything else we have seen before, no big deal. But line 2, hey, this is a new kind of statement. It's a return statement. We haven't seen this before. And then we also have line 6. That's also new, because before we always have an invoke all by itself on the line. But this time, I'm using invoke 5 as a part of an assignment statement. It looks like invoke 5 is somehow going to produce a value to serve as the right-hand side of an assignment statement, and I'm storing that value into my local variable x. Okay, so there are little pieces here that most of you would think, okay, I think I know what this program is going to do. X ends up with a value of 5. Okay, that part is kind of obvious because the subroutine is also called 5. Okay, but the question is, how am I representing this in a trace? So here comes the part that can be a little bit confusing at first. All right, so we'll do a trace here. We have line number. The precondition has nothing to say because we do not have any global variables in this case. So we start execution on line 8. We invoke main. Main has one local variable, so we have to reserve one column for the return line number. So we continue execution at post, and then we reserve one column for x, which is my local variable. All local variables in C and C++, they all start with unknown values unless you use a initialized local variable, which we don't talk about in this class. So now we continue execution in the subroutine main, starting on line 6. Okay? Line 6 looks a little bit funky, but if you just look at this, should I perform the assignment operation first, or do you think I should invoke 5 first? Just looking at line 6. We have to invoke 5. I don't really know what it's going to do, but it seems like that's something I have to do first because in an assignment statement, we evaluate the right-hand side, and then we copy that value to the left-hand side. So we have to invoke 5 first. Okay, well, we know how to invoke stuff. So we can say, return line number, and oh, now we have a problem, don't we? Because if I just use a return line number to indicate what I have to do after the subroutine is finished, I have a problem. Because now I have to say, well, should I say line 6? Because I still have that leftover operation called an assignment to do. I have to copy this value to local variable x. But if I say line 6, isn't that going to invoke 5 again? Now, if I say line 7, that means I'm skipping over the assignment portion, which means x is not going to be changed. So if I say line 6, that's wrong. If I say line 7, that's wrong too. Line 8? Oh, that's even that's even worse, right? We have a problem here. We cannot use, well, that means we cannot use the concept of a single return line number anymore. Okay? So from here on, when you have a subroutine that returns a value, I'm going to label the column not a return line number, just return information. Information that I need in order to return from a subroutine. That's basically what it is. Okay? And it's more than just a line number, because what I need now is to say, when the subroutine 5 is done, what I need to do is to go to line 6, but I'm going to remind myself what else on line 6 I have to do after the return. Okay? That is the rationale of the change. So the change is basically saying the return info, the information that I need to perform the return, will indicate line 6. So we still need to indicate line 6 is where we need to go back to, but we also indicate what else on line 6 we have to do, the assignment operation. But then what about invoke 5 itself? Well, invoke 5 itself is going to be represented by a question mark, because the invocation of 5, the subroutine 5, is going to give me the value represented by the question mark here, so that I can complete the assignment operation. Are we doing okay so far with the notation? The invocation itself is replaced by a single question mark, because it is a placeholder for the value that will be filled in by the subroutine. Okay? All right, so let's move on, because when we get to the return statement, this will be kind of more clear. Okay, so return info is just like this. The subroutine 5 has no local variables and no parameters whatsoever, so I don't have to allocate column E for anything. Now I continue execution on line 2. Line 2 sets return 5. What does that mean? Return 5 in the subroutine 5 simply means the value of the invocation is the numeric value 5. How do you think 5 as a value relates to the question mark in return info? It's going to take the place, right? It's going to take the place of the question mark. We just resolved what that question mark is supposed to be. Okay, so that means when you execute a return statement, it is going to look at the rightmost return info column. We copy and paste the entire thing, and then the only thing you have to do with the clone, the copy, is to replace the question mark with the actual value that we're returning, because we are just resolving what that value is supposed to be. So does that mean that we should also update column C and change that to 5? No, it's not time yet to do that, okay? So the return statement doesn't do a single thing about what the return info column is saying. All it's going to do is to replace the question mark with a concrete value. That's all it's going to do, okay? We're not going to do anything about line 6 at this point. Instead, in this class, we move on to line 3. Okay, we just march right on onto line 3. Line 3 is going to do its usual thing. Okay, but this time it's a little bit tricky. I still haven't got a really good idea of how to represent this. So what I'm going to do is I'm going to say, before we destroy or deallocate column D, I'm going to make a note of what else I have to do on line 6. So in this particular case, I'm just going to copy the entire thing. Okay? In other words, by the time I get to row 9 in the trace, I know that I'm not only getting back to onto line 6, this is what else on line 6 that I have to do. Okay? But after I make use of this information, I can say, this column is no longer in use. I can now deallocate it. And once I deallocate it, I continue execution using the line number column. And now we're back on the line 6. Hey, we know how to do this, right? We have an assignment statement. The right-hand side is 5. The left-hand side is my local variable x. Now we can actually go ahead and execute the assignment statement. So the x is now updated to a value of 5. And then we move on to line 7. That portion you know already. Line 7 is going to refer to the rightmost return line number, which has post in it. Make a note. And then we can deallocate those 2 columns. And we're done. So this is what I'm going to use in this class to represent the action of returning a value from a subroutine, which seems to be really, really cumbersome, but it is representing what kind of happens when you have a subroutine that returns a value. Are we doing okay so far with this example? Okay. Let's move on to a second example. Okay. So we'll go ahead and move on. I'm going to use the same spreadsheet, so I don't end up with tons of documents. Because what I'm going to do is I'm just being lazy here and just do a whole bunch of copying and pasting. I'm not even adding a new line in this case. What I'm going to do is to say, hey, if we can deal with one invoke on line 6, can we deal with multiple invoke on the same line? In other words, what if I do something like this? We have about 3 minutes and a half. That may be a little bit short to deal with this one, and I'll try my best. Okay, so we got line number, nothing to talk about in the precondition. Line 8 is going to invoke main. Return line number is post. And it has one local variable x, which starts with an unknown value. Then we continue execution inside the main subroutine on line 6. Okay, we know how to deal with this one. We need return info instead of return line number because we have to go back onto line 6. But this time, when we go back to line 6, we got multiple things to do. Okay, so return info this time is a little bit interesting because we have to say that we have to go back to line 6, but I can only do one invocation at a time. Okay, now because of the convention of we are reading from left to right in English, I'm going to use the same convention here. So I'm going to say I can resolve the first invocation first. Okay, but when I'm doing that, the second invocation remains unresolved. Okay, so it is still the same as before, invoke 5, because I'm not dealing with that invocation at this point. Then we get into the subroutine, go to line 2. Line 2 is return 5, which means we copy and paste the return info cell, change the question mark to the value that we are returning, which is a 5 here, and then we move on to line 3. Line 3 does the actual return. We copy and paste the entire return info cell just so that we know what else we have to do. And then we have no use of column D anymore. We deallocate it. So now it's deallocated. And now we are back onto line 6. It's looking a little bit better than before, but we still got one more invocation to do. So this is the second time that we invoke 5. So now we say, okay, now it's time to take care of the second invoke 5. And to take care of that invoke 5, we reallocate column D to be my return info cell.
We shouldn't update X already? Not yet?
Nope. I don't know how to update X yet because I don't know what is 5 plus invoke 5. So I have to resolve the second invoke 5 before I can do the addition, and then I can do the assignment. So in this case, I have another invoke, but I can reuse column D because column D is now free again. And this time it has a return info of line 6. and it is x gets 5 plus, whoops, cannot type and I cannot see what I'm typing. 5 plus invoke 5, like that. Are we still doing okay so far? Okay. And then after I remember where I'm supposed to go back to, I can now continue execution in the subroutine on line 2 again. Line 2 is once again doing exactly the same thing as before. Oops, I forgot one thing. The invoke itself is supposed to be replaced with a single question mark because that's the placeholder of the return value. Okay, so once I do that, I can copy and paste it. And because I'm executing a return statement, I change the question mark to a 5. Now this is one thing that you can remember. That should only be one single question mark in the return info. If you end up with 2, then something is wrong. Okay, there should only be one question mark in the return info cell. After line 2, we get to line 3. Line 3 says, let's remember where we're supposed to go back to, and then deallocate the return info cell. So now we are back onto line 6 again. This is the third time we get to line 6. But this time is okay because we know what is 5, we know what is 5, we know what is plus, so we know what is 5 plus 5, which is 10. And we also know what is assignment, so we know that we have to update the value of x with a value of 10. So now x gets a value of 10. And that concludes the execution of line 6. The rest is not too challenging. We just look up the rightmost return line number, which is post, and then we deallocate both of those columns, and we are done. So some of you may have an additional question of where can we find material that talks about this kind of convoluted concept? I would just kind of shamelessly point to my own website. It is all there already. All of this stuff is already there. So shameless plug, yes.